Hello students, today we are going to revise the chapter Lines and Angles of class 7 mathematics. First we will revise the basic terminology that we generally associate. Line segment. A line segment is a straight path which has two endpoints. You can see in the figure the two endpoints. Similarly, a line. If we extend the two endpoints of a line segment endlessly, we get a line. Now, angles. An angle is formed when lines or line segments meet. In the first figure, you can see the two line segments AB and BC. They meet at B. And in the second figure, two lines YZ and WX, they intersect at a point O. In the first figure, we write the angle as ABC, and in the second figure, we write the angles as XOY, ZOW, YOW, XOZ. These are the different angles. Now, related angles. First one is complementary angles. When the sum of two angles is 90 degree, the angles are said to be complementary angle. You can see in the figure, one angle is 25 degree, the other angle is 65 degree, and the sum of two angles is 90 degree. So the two angles are complementary to each other. Next, supplementary angles. When the sum of two angles is 180 degree, then the angles are said to be supplementary angles. If two angles are supplementary, then each angle is said to be the supplement of each other. See the figure, one angle is 120 degree and the other angle is 60 degree. So the sum of the two angle is 180 degree. Now pair of lines, intersecting lines. Two lines intersect if they have a point in common. This common point is called point of intersection. See in the first figure, two lines L and M, they have a common point C, and that point C is known as point of intersection. Transversal. A line that intersects two or more lines at distinct points is called transversal line. You might have seen a road crossing two or more roads or a railway line crossing several other lines. These give an idea of transversals. In the figure you can see here X and Y are two lines. They are intersected by another line P, and the two lines they are intersected at two distinct points A and B. Angles made by a transversal. Angles made by a transversal. When a transversal intersects two lines, then they make different angles. You can see in the figure two lines, they are intersected by another transversal, forming angles 1, 2, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8. Now we have some special name for these angles. Now between the two lines, see the angles 3, 4, 5, 6. They are called interior angles. And outside these two lines are angles 1, 2, 7 and 8. They are exterior angles. Now pair of corresponding angles. See in the figure angle 1 and angle 5. Angle 2 and angle 6. angle 3 and angle 7, angle 4 and angle 8. They are pairs of corresponding angles. Next, pairs of alternate interior angles. Angle 3 and angle 6. Angle 4 and angle 5. Then pair of alternate exterior angles. Angle 1 and angle 8. Angle 2 and angle 7. Pair of interior angles on the same side of the transversal. Sometimes they are known as co-interior angle also. Angle 3 and angle 5. Angle 4 and angle 6. Now, when the two lines are parallel, or when two parallel lines are intersected by a transversal, then there are some special relations between these two angles, these pair of angles. If the two lines never meet with each other, then they are called parallel lines. If we have a transversal on two parallel lines, then first one, each pair of corresponding angles are equal. Each pair of corresponding angles are equal. You can see in the figure, angle 3 is equal to angle 7, angle 4 is equal to angle 8, angle 1 is equal to angle 5, and angle 2 is equal to angle 6. They are all pair of corresponding angles. Next, each pair of alternate interior angles are equal. Alternate interior angles. Angle 3 and angle 6. Angle 4 and angle 5. They are equal. So angle 3 is equal to angle 6. Angle 4 is equal to angle 5. Each pair of interior angles on the same side of the transversal, or what I already said, they are called as co-interior angles. They are supplementary. Angle 3 plus angle 5 is equal to 180 degree. Angle 4 plus angle 6 is equal to 180 degree. Now, checking for parallel lines. These are the conditions when two lines are said to be parallel. This is the inverse of the above properties of the transversal of parallel lines. When a transversal cuts two lines such that the pairs of corresponding angles are equal, then the two lines have to be parallel. When a transversal cuts two lines such that the pairs of alternate interior angles are equal, then the two lines have to be parallel. When a transversal cuts two lines such that the pairs of interior angles on the same side of the transversal are supplementary, then the two lines have to be parallel. Now, based on the above concepts, we will discuss two questions from the textbook exercise. Exercise 5.2, question number 1. The question is, state the property that is used in each of the following statements. See the figure. In the figure, you can see A and B, two parallel lines are there, and another two transversals are there, and different angles are marked 1, 2, 3, 4, 5, 6, 7, and 8. The first question, if A is parallel to B, angle 1 is equal to angle 5. See the figure, you can see angle 1 and 5. What type of angles they are? They are a pair of corresponding angles. So angle 1 is equal to angle 5. Reason is pair of corresponding angles. Now second question. If angle 4 is equal to angle 6, see the figure. If angle 4 is equal to angle 6, then A is parallel to B. In the figure you can see clearly angle 4 and angle 6. What type of angles they are? They are a pair of alternate interior angles. And if a pair of alternate interior angles are equal, then the two lines have to be parallel. Hence, A is parallel to B. Third question. If angle 4 plus angle 5, see the figure carefully. If angle 4 plus angle 5 is equal to 180 degree, then A is parallel to B. Now from the figure it is clear, angle 4 and angle 5, they are interior angles on the same side of the transversal, or we can say they are co-interior angles. So if the sum of interior angles on the same side of the transversal is 180 degree, then the lines are parallel. Hence, A is parallel to B. Now, let us go to question number 5 of exercise 5.2 of the textbook. In the given figure, the arms of two angles are parallel. If angle ABC is equal to 70 degree, then find angle DGC